So there's an old joke amongst the woodworking fraternity that a house builder works to the nearest half an inch, a carpenter works to the nearest 1/16 of an inch, a joiner works to the nearest 1/64 of an inch, and a boat builder works to the nearest boat. And having worked in all those fields, I know there's an element of truth in that. Nowadays we talk in terms of millimetres, obviously, but it illustrates the point that whatever we're doing, the context dictates the level of accuracy that we need to work at. So furniture making students at the start of their journey are thinking, well, how accurate do I need to be? You may be thinking, how accurate do I need to be? And to illustrate, the last commercial workshop that I was working in, the drawings that we were working from were set out to the nearest 0.1 of a millimetre. So, for example, 10.03 or 10.3 millimetres. And so 0.1 of a millimetre. It's very, very tight, very difficult sort of level of accuracy to work at in wood and with the sort of hand tools that we're often using. So the first thing to remember is that you're just starting. You're not expected to work to that sort of level of accuracy at this stage. So don't set the bar too high and don't panic if you're not quite getting that level of accuracy yet. However, this tutorial is designed to give you a few hints and tips, a few starts for your own research and your own practice to develop the accuracy of the work that you can do. So practice is the first giveaway. That's the number one technique really for improving your accuracy is to practice and practice. And hopefully you're enjoying what you're doing. So the practice isn't a chore. You're just making new things, new projects, and each one gets a little bit better as you go along. So that will naturally improve your skills, improve your accuracy. The other thing is sharp tools, and we're going to deal with tool sharpening in a future tutorial. So they're your two keys. After that, the next layer of techniques for improving accuracy is what we're going to deal with in the next 5 or 10 minutes in this tutorial. So before we can start marking out our mortise and tenon joint, our dovetail joint, or whatever joint we're making, whatever piece of work we're doing, we are training ourselves to take our dimensions straight from the drawing. So we've got a drawing here, the same one that we've used in previous tutorials. And people have come back to me and they've said they find it quite difficult to get the dimensions accurately from the drawing onto the piece of wood. So a couple of techniques, a couple of hints to make that a little bit easier and increase the accuracy again. One is to use your very fine 2H pencil even for your drawing. This drawing I've done with an HB pencil so that it's nice and visible. You can see it on camera as we're doing this tutorial. Ideally you'd want a finer line and that keeps the accuracy of your final work much better because the accuracy of your drawing is better. It takes out the variation of thickness of the line, and if we're trying to work to 0.5 of a millimetre, if we're trying to work to less than a millimetre, the fact that we've got a line there that is pretty much a millimetre in itself, or do you go to one side, do you go to the other, do you go to the middle? If you use a very sharp line from a hard pencil, it takes some of that inaccuracy out of the picture. So that's how we draw. It might be a little bit difficult to see, but for that fine quality of work, it does add to the finished product. The next thing that's quite difficult is taking the lines from your drawing onto your piece of wood. And we talked last time about using one of these, using a set square to transfer lines from the drawing onto the piece of work. Now let's say that we're doing this rail and we're using this square to bring the line up. In order to get everything nice and accurately, obviously this needs to be the right length, it needs to be situated on the drawing nice and accurately, but there's a little bit of free play based on this corner. If this corner isn't nice and sharp, where it meets the drawing, it can again give you a little bit of a fiddle factor. It can easily put 0.5 millimetre or a millimetre of inaccuracy in. So if your lines are giving you a millimetre of here or there, if this is giving you a millimetre, already you could be 2 millimetres out before you've put a line on your piece of wood. So one thing that I do is I keep that corner nice and sharp. I do that with a really sharp block plane, set with the mouth nice and tight. So this piece of of steel here in the front of the plane is adjustable, that can move in and out, and I set that as pretty much as close to the blade as I can get it, and I set the blade very, very fine. And then just set this up in my bench hook and take a fine shaving off. So you've got a really fine shaving of plastic. It keeps that corner nice and sharp, but you've got to just check that it's still perfectly flat and perfectly square. So hopefully that'll help a little bit with transferring measurements. One final tip, just to keep everything consistent as you're going through a drawing, very often you'll have similar dimensions. These shoulder lines are the same for the bottom rail and the top rail. So let's just imagine, I know it doesn't look like it, but let's imagine that this is your top rail, this is your bottom rail. We transfer the measurements from the drawing to our bottom rail. Then we clamp the two together and mark out while the two are clamped together. You might have 3 or 4 different components if you've got 4 legs for a table or a chair. And you're marking out the mortise positions. You clamp them all together, mark them all in one go, and you know that everything's going to be parallel. And even if you've got a tiny little bit of inaccuracy in your marking out, it's consistent. So rather than something that's not quite square, you might have something that's just a fraction too big or too small, which is easier to deal with than a frame that's not perfectly square. We're going to look at some tools and techniques to help you to mark out that little bit more accurately. And eventually, hopefully, you build up to the level where you can work to 0.1 of a millimetre like a professional. So we're familiar with the mortise and tenon joint. We're going to use marking out and cutting a tenon because we're familiar with it, but try and remember that everything that we're looking at now can be transferred to other contexts. That's what we need to do really, is to try and pick up these techniques and then use them when we're cutting dovetails or whatever sort of joints and woodworking that we're doing. It all helps, it all translates into more accurate work if we can pick up some of these key techniques. And we're going to look at some tools that we'll be able to use to improve our accuracy. The first thing we look at is an engineer's square. So we were using a combination square last week, which is pretty accurate, but this engineer's square is designed to be just that little bit more stable and accurate. It's square and it stays square. So we're going to imagine that we've already got a mark on this tenon piece, and we're going to square round our shoulder line. And remember that we start with the face side or the face edge, and we could use a pencil. Remember that we're using a sharp 2H pencil at least. Pencils are graded from B to H, B being pretty soft, H being hard, so at least a 2H pencil. And we could mark all the way around, remembering to work from face side and face edge. However, for the sake of this demonstration, we're going to use this tool. It's a marking knife, and it's sharpened like a chisel. It's got one very, very flat face, and it's got one beveled face, and it needs to be really razor sharp to work. And what we're going to do is hold that flat on the bench so everything's nice and stable. We hold the flat edge to the edge of the square, and we mark all the way around, as we did with the pencil before. And the reason that we do this is this cut line stays very straight, it's very accurate, and it gives us a start for the saw that we're going to use when we start cutting that line. It's got a little shoulder for the saw to drop into to guide the saw and keep it nice and straight. It's also more accurate than a pencil because it stays very, very sharp. The hardest pencil is still going to wear out. You're going to end up with a dimension to your line, and this stays pretty much with that shoulder exactly where we want it to be. So that's tip number 1. We could draw around that line to emphasise the shoulder line to make it a bit clearer to see, but if we can avoid doing that, if we don't need to do that, don't do it, because then we avoid having a pencil line that we need to rub out in our finished workpiece. So there's our shoulder line all marked out. And the next thing that we did the last time we were working on tenons was we picked up our mortise gauge and we set that up to our required dimensions. This is a very accurate tool. It's an ideal tool for doing what we're doing, especially in softwood. When we get onto working in hardwood, sometimes we find again that the level of accuracy that we get with this isn't quite up to what we're aiming for. A couple of things that we can do. One is we get a very fine file. A nail file would do that, or a Swiss file like this, and we make sure the points of our mortise gauge are really nice and sharp, and that'll just keep the accuracy up. As these get used, especially on hardwoods, the points can get blunt, and then again the dimension of your marked line can stray from what you want. It can start to get quite fat, so then there's a little bit of leeway on our final dimensions. That's one thing we can do. And then once we make sure that those 2 points are very sharp, we use it in the way that we were shown in previous tutorials. The alternative to that, it's a Veritas gauge, and it's got a couple of advantages over our traditional English style marking out gauge. One is that the cutting edge is very, very fine, and it's also got an angle to it. If I can just show you on the board, the edge that we've got here is straight here and angled here. A little bit like the cutting knife that we're using. If you imagine that as a blown up version of what we've got here. So that what's actually doing the marking here is not only very sharp, it's also very fixed to this dimension, rather than what we've got with a traditional marking gauge, where if we set the point to here, to this dimension, we've got a little bit of leeway because of the shape of the needle that's actually doing the marking. So you can see it takes a little bit of the inaccuracy out that's inherent in this sort of design with a needle shaped design by using a flat cutting disc. The other advantage that we have is it's very adjustable, and we adjust it by, we can slide the stock up and down on this rod, and then for our fine adjustment we can turn these two knurled nuts together, lock those two knurled nuts, unlock this locking screw here, and then if we turn the stock it will move gradually that way or that way according to how much we turn it, so we can get a very fine adjustment on our Veritas marking gauge. You can get these with two wheels on them for marking out mortises, but you can mark out a mortise with this one by going from one side and then from the other side. It's a little bit more work, but it's an awful lot cheaper to buy one of these than to buy one with the two cutters on it. So how do we set this up? We could use a ruler. We could take the dimensions straight from our drawing. It's quite difficult with this. You'd have to, it'd be quite fiddly to get your dimensions straight off your drawing. But again, to increase the accuracy of the work that we're doing, we're going to have a look at another tool that's quite useful. And that's this. It's a vernier gauge. So it looks quite expensive. It's relatively cheap. One of these you can get for probably about 20 or 30 pounds. And it's digital. So switch it on. You can get them that aren't digital, but I use a digital one. And it's very, very accurate. You can set a dimension very, very accurately on it. So let's say I want 12 millimeters. I set that to exactly 12 millimeters on the gauge and lock that off, and that's going to stay at 12 millimeters, and it's very accurate. So I could now use that dimension, mark it on my workpiece with a marking knife. Probably if we're working to this sort of level of accuracy, the pencil, we've gone beyond using a pencil really. It's probably there's too much variation really on the dimension of the line that we're putting on. So we could mark that straight with the marking knife, but we could cut out the middleman and transfer that dimension straight to our marking gauge. So if you notice, we've got, for that dimension of 12 millimeters, which has moved slightly, I'm just going to put that back on 12. Do have to be a little bit careful. It's so fine an adjustment that it can move quite easily. We've got 12 millimeters here. We've got 12 millimeters here. We've got 12 millimeters on this depth stop here. we've also got 12 millimeters between that face, and that's the one that we tend to use quite a lot. So I'm going to set my marking gauge between those two faces and lock it off. I'm just going to check that it's still spot on, dead accurate. Sometimes locking that can move things a little bit. And then I'm going to mark all the way around for my tenon, which is set with a nice 12 millimeter shoulder. So I'll take that all the way around as we've done before with the traditional marking gauge, and then I'll have to just turn it round and go from the other shoulder. And assuming that those two shoulders are the same dimension, then I don't have to move anything. Obviously, if that, for any reason, that was 11 millimeters or 14 millimeters, then I'd have to readjust this and do it again. But for most cases, things are going to be symmetrical, so that setup will work all the way around there. So the next thing that we're going to look at, the next technique to improve the accuracy and the quality of the work that we're doing, again, we're using a mortise and tenon as our example, but remember that we're discussing techniques that you can use in all sorts of contexts. Try and think how you could use this on your project work, even if it doesn't involve mortise and tenon joints. So we've had a look at a couple of ways to improve the accuracy of what we're doing, some tools that we might buy as and when we decide that we're prepared to invest that sort of money and time in improving our skills. And we've hopefully got some of the key elements of marking out nailed. Okay, so the next thing that we're going to do is just as when we cut the first mortise and tenon, we're going to start doing some cutting out. And the difference this week is that we're going to use Japanese saws. So if you have a look on the bench here, you can see some reasonably good quality mid-range Japanese saws that serve the same purpose as European saws but work on quite a different principle. We've got this one, which is the equivalent of a dovetail saw. This one, which would be the equivalent of a European tenon saw, and you can see that both of them have a back the same as the European saws. And then we've got a panel saw with no back, which can obviously go through deeper timber. So we could, if we were doing long cuts along the grain, we could use this, or across the grain on wide boards like that. These are obviously limited to the depth that they can go to due to the shape of the back on there. So very much like a tenon saw or a dovetail saw. And we're going to use this one, the tenon saw. They have Japanese names and I'm not going to try to pronounce them. So we'll call them by their English names. So we're going to use our tenon saw to cut the cheek line of our tenon that we've just marked out with the Veritas gauge. Okay. The difference between using one of these and a European saw is that they cut on the pull stroke. So as you pull, they're cutting. As you go forward, they're just returning to the start position to start working again. And because they do that, they can be much thinner than a European saw, and that's probably the key advantage. They cut a very fine curve. They're extremely sharp, but there's a disadvantage in that it's very easy to buckle them. So before you start working, just check down the saw, make sure it's nice and straight. And they're so thin that if there's a little bit of a kink in it, you can sometimes just push it out with your thumb like that. So check that it's nice and sharp, and then we should be ready to go. And other than that, the technique is pretty much the same as for European sawing. Some people might want to start here. I can see this line, I can see this line, and I can go down at my angle. I tend to start at the back here and put in a nice straight cut all along the top. And we're going to take that line down, use this edge as a pivot where my thumb is. And take that line all the way down. So once we've sawn our cheek lines, we saw our shoulder lines, and again we'll do that over here using a bench hook, same as with the European saw. One little difference that we might find is that because of the nature of the saw, we end up dropping quite low. It's got a long handle, And to get our angle on this back cut, on this shoulder here, we'll probably end up, if we set our bench hook up here, where we did with the European saw, we're going to be sort of knocking into the bench. So we set up over here, and then we've got plenty of leeway. We can move around. So having cut our tenon, and you can see here we've got a haunched tenon ready to go. A few little fine points if we want to really get the best from our joint making, especially if there's any element of this joint that's going to show. If this is a through tenon, then that end is going to show, and how that fits into the mortise is going to show. Really, cutting a mortise is down to practice and using the right chisel and using very sharp chisels. I don't really need to demonstrate that, but there are some ways to make our tenon just that little bit better, so it's a really nice fit without any visible glue lines showing around as it's in its mortise. So we go back to our vernier gauge, and we've got a dimension from our drawing or from our own design of what the width of this tenon should be. So we can use our vernier gauge to check it. So we switch it on, check that it's on 0. Sometimes it drifts a little bit, so you've got a 0 button on most of these. Make sure it's in millimetres, not inches, if you're working in millimetres. And then we check the width of that tenon and check it in a few places. It should be consistent, and we can see from this that we've got a little bit of inconsistency. We've got 12.13 here, and we've got 12.0 there. So we're 0.13 of a millimetre out, which is probably, for most work, that's quite good. We've got 0.17 there, 0.15, 14. So we're pretty consistent. If we're doing the very best quality work though, we might want to just trim that down a little bit, or you might find you've put your vernier on there and you've got maybe 0.5 millimetre of run out, which will show up in a through tenon. That will show up in the mortise. That will show up as a strong glue line or even a gap, which we don't really want, especially if we're trying to do really good quality work. So what can we do about that? A couple of options. We can use a shoulder plane, and the difference between this shoulder plane and a typical bench plane, like this block plane, is that the blade runs right from one side to the other side of the plane. So it can get right into corners. That's what that does for us. There are other planes with full width blades. We could use any of those types of planes for what we're going to do next. The main thing is it's got to be extremely sharp and it's got to be extremely finely set. So it's just taking the smallest shaving that we can possibly manage off our workpiece. So we drop that into the bench. We can either work in the vise or off the bench hook. Remember where our fat points were, just about here. And very gently, very carefully, just take a really fine shaving off. And I don't know if you can see that. That's literally just a few fractions of a shaving really coming off there. So let's see if that's made any difference. So that's gone down to 12.07. So just that tiny little bit of work has taken 0.07 of a millimetre off. So a little bit more off the other side. This time I'm going to use something else. Working with one of these is really quite tricky, and setting it up is really quite tricky, and they're quite expensive to buy. Something that you can do that's much cheaper is make yourself a really accurate sanding block. What you need is a nice square flat piece of timber. This is plywood, MDF is good, anything that can be cut nice and accurately. And some carpet tape and some abrasive paper. I usually set them up with some a fairly coarse grade on one side and a fairly fine grade on the other. I usually, at the start of any project or any week, I probably make myself several of these. And depending on your project, you can make them all sorts of different shapes. You can even make them with curved surfaces if you're doing curved work. So they're really useful, a really excellent tool. Cheap as chips, obviously. So I can take my sanding block and use the coarse side, take a little bit off, and then clean it up with the with the finer side. They're a throwaway item, obviously. By the time you've used that for 20 minutes, half an hour, it's probably to be thrown away and you get the next one. That's why I make several at the beginning of the day if I'm going to be doing a lot of this sort of work. So let's see if that's made any difference. Get the vernier back on there, and I'm down to, oops, well, it depends on how hard I push it in. 11.9, well, there, got bang on 12 millimetres, which is what I was aiming for. So you can see with a little bit of care, you can get an almost perfect dimension. You can take 0.1 of a millimetre off as you go along, even less. The other thing that we might have to look at is this shoulder line here. A little bit more difficult to address that. We can clean that up with some very sharp chisel cuts straight down. And what can help with that is if we have a piece of scrap wood and we clamp that to the shoulder, that gives a nice guide for our chisel to run down if we want to clean up that shoulder, maybe alter the dimensions of that and get that absolutely perfect with a very, very sharp, broad bevel edge chisel. Another thing that we can do is use our shoulder plane for the purpose that it was intended for. It's called a shoulder plane because it was originally made for cleaning up the shoulders of mortise and tenon joints like this. If we're going to use the shoulder plane, we need a piece of scrap wood, and we pop that on the back. Perfectly flush with the shoulders. Set your workpiece nice and low in the vise, nice and tight, and then we can just carefully, and again really gently and really with a really fine set, clean up those shoulders a little bit if we need to. Trying to keep everything nice and square. That's juddering a little bit, so I just need to back that off. So I undo the adjuster. Just back that off just a tad. So even though it was cutting a very, very fine shaving off here on linear grain, now I'm working on end grain, it needs to be even finer still. So just a little really careful bit of work on there to get that shoulder perfect, and we can check it with our engineer's square to make sure everything's as we wish it to be. So I can't see any daylight there, that's nice and square, and it's running all the way around. It's nice and square and parallel all the way around. So once that's glued up, that should be pretty much a perfect joint. And if we are doing a through tenon, where this will be seen, that's going to be a perfect joint too, and it'll look really good and add to the quality of the piece that we're trying to do.